What we factored so far in section 8.6 was always in this form. The point being, the only coefficient in front of x was the understood 1. But today we're going to learn how to factor quadratic trinomials where they have ax squared plus bx plus c, where a, the coefficient in front of x squared, does not equal 1. So good news is there's a pretty smooth, clear set of steps that will help us factor these. It's called the bottoms-up method. And it's one that I did not learn until I was a teacher, and I really wish I had learned it as a student. So, let's try it. Let's say we want to factor, sorry about that, 6x squared plus 5x minus 4. So factoring rule number 1, if there is anything, a number or a variable, that all the terms have in common, factor that out first. Well, as you look here, they don't all have an x, and there's no number that goes evenly into 6, 5, and 4, other than 1, of course. Step 2, multiply a, which in this case is 6, it's the coefficient in front of x squared, times c, which is negative 4, the constant. So 6 times negative 4 is negative 24. Now, we really hate what makes this more complicated, and that's the 6. So you know what we're going to do? We're going to ignore it. We're going to kill it. I'm not sure why I did that sound effect. Sorry. And we're going to put the minus 24 in where the 4 was. So we removed the 6, because it's a pain. We'll get rid of it. And we're going to change the constant to minus 24. And we're going to factor it just like we did before. Okay, so we want factors of negative 24. That means we need one positive and one negative. And since this is a positive, I know the bigger one will have to be positive. So negative 1 and 24 adds up to 23. Negative 2 and 12 adds up to 10. Negative 3 and 8 adds up to 5. And we have what we need. So it would be x plus 8, that's the positive one. X minus 3, that's the negative one. However, if you've ever watched The Walking Dead, which I actually haven't, I just know what it's about, you know that when we kill something, when we bury it, it tends to come back. So remember how I just got rid of that 6? Well, now it's going to come back and seek to divide and conquer. So this is the next step that's talked about here. Divide the two numbers we put in parentheses, 8 and 3, by 6. We need to reduce the fractions if possible. So 8 over 6 reduces to 4 over 3. 3 over 6 reduces to 1/2. Now sometimes when you reduce, it'll come out to a whole number. Like if it had been 8 divided by 2, we would have just gotten 4. We'd be done with that part. But when it reduces to a fraction, this is why it gets the term bottoms up. Because what we do next is we bring the bottom up. So that becomes 3x plus 4. And that becomes 2x minus 1. And I won't make you do this very often, but let's just test it, make sure it works. Let's make sure when we FOIL, it gives us what we started with. So 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. 4 times 2x is 8x. 4 times negative 1 is negative 4. And then if we combine those like terms, negative 3x plus 8x is 5x. And that is exactly what we started with. So let's practice these. So 7 times 4 is 28. Everything's positive. So 1 and 28, that adds up to 29. So we're all set. First one we tried. So I do an x plus 1, x plus 28. But that 7, gosh darn it, it comes back and tries to divide and conquer us. Well, we can't reduce 1 over 7, so it's just 1/7. 28 divided by 7 is 4. So if you remember on the first example on the front, we had fractions in both of them. This, we only have fraction in one of them. So this piece, x plus 4, is already exactly as it needs to be. But this one, we'll have to move it up. So it's 7x plus 1 times x plus 4. Okay, this next one, 5 times negative 9 is negative 45. And we know that has to be a positive and a negative number. And the bigger one would be positive. So I could try 45 and negative 1. Let's see, 15 and negative 3. And we're set. That's what we needed. So we'll do x minus 15. Plus 15, positive, and x minus 3. And then that darn 5 that's causing problems to begin with comes back again. We can reduce this one to just x plus 3. This can't be reduced, so you do bring it up and make it 5x minus 3. But don't forget to reduce if possible before you try to bring anything up. Okay, now I've been forgetting to check rule number 1, but thankfully there was nothing that all three of these had in common. There was nothing all three of these had in common, but there is something all three of these have in common. So you gotta watch out or you're gonna get bit forgetting to see if there's anything that all the terms have in common. All these are divisible by 3, so I can factor out of 3. 3 divided by 3 is 1, so I get m squared. 15 divided by 3 is 5, so I get 5m. 18 divided by 3 is 6. So this is one that looks like it's one of the more complicated ones, when in fact, once you factor out the 3, it's pretty straightforward. So factors of 6, see 1 and 6, that adds up to 7, but 2 and 3 adds up to 5. So we get 3, don't forget that, that's a common mistake I see. People will factor out the 3 and then it disappears from their answer. It's still part of what we started with, so we still have to include it. And we get m plus 2, m plus 3. Okay, this one, there's nothing they all have in common. So I do 3 times 20, which is 60. It is a positive number, so that means these have to be the same signs, both positive or both negative. Oh, sorry, there's a typo. That should have an X right there. We will have to use two negative numbers. So negative 1, negative 60 is negative 61. Negative 2 and negative 30, negative 32. Negative 3, negative 20 is negative 23. Negative 4, negative 15 is negative 19. Negative 5, negative 12, negative 17. There it is. That's the one we wanted, negative 17. So I'll write x minus 5 and x minus 12. And that blasted 3 comes back, seeks to divide and conquer. 5/3 won't reduce, so we can bring the bottom up. 12 divided by 3 is 4, so we just get x minus 4. Okay, nothing that all of these have in common. So I do 4 times 5, I get a positive 20. And since the middle term is negative, that means they'll both have to be negative. So negative 1 and negative 20 is negative 21. Negative 2 and negative 10 is negative 12. Negative 4 and negative 5 is negative 9. Huh. That's all the things that multiply to be 20, but none of them add up to that middle number. So that means this is unfactorable. There's no way to break this down into two pieces. But we showed that by looking at these factors and seeing what their sums were. So by displaying there's no combination that multiplies to be 20 and adds up to -3, that's how we've proven this is unfactorable. Nothing all three have in common, so I go straight to step 2, which is multiplying these together. It's a -10. Since it's a negative, we'll have one positive and one negative, and the bigger one has to be positive. So let's see, 10 and -1 adds up to 9. 5 and -2 adds up to 3. And there we got it. So we'll do x plus 5, x minus 2. Then that blasted 2 comes back from the dead and seeks to divide and conquer. 5 over 2 cannot be reduced, so we bring the bottom up and make it 2x plus 5. 2 over 2 is 1. Okay, these last two. Nothing they all have in common. So we do 2 times 1 is 2. So you got to think, -2. And there's only one pair of numbers that multiplies to be 2, and that's 1 and 2. And the bigger one has to be negative, and that works out well because 1 plus -2 is -1. So we'll do y plus 1, y minus 2. Then we'll divide both of these by 2. This is already fully reduced, so I bring the 2 up and get 2y plus 1. This reduces to 1, giving us our final answer. Okay, number 8. Again, we got to think about rule number 1. There is something all three of them have in common, and that's 5. So I can factor out of 5. 10 divided by 5 is 2, so we get 2r squared. 35 divided by 5 is 7. And 30 divided by 5 is 6. So even though we were able to factor out of 5, we still do have to do the bottoms up method. Whereas in number 3, once we factored out the 3, we could just do the normal method. But here, it still is necessary to factor out the 5. If you try to use the bottoms up method without factoring the 5, it won't work. You won't get the right answer. So you do have to factor out what they have in common first. Now, we do 2 times 6 is 12. It's positive 12, but they add up to a negative number, so we need them to both be negative. So -1, -12, that adds up to -13. -2 and -6 adds up to -8. -3 and -4, and there it is. So we have r minus 3 and r minus 4. And don't forget to keep including that 5 right there. We do divide this by 2, because that's the a we got after factoring out the 5. So we bring this bottom up, giving us 5 times 2r minus 3, and this reduces to 2.